Good morning, everyone. I'm going to have several videos for you today. So what we're going to do is I'm going to make videos according to the topics within our notes. So some of you guys need to catch up on your notes. So this is going to be a way we can do this. This is going to be on YouTube, so you can pause and stop whenever you need. And it just will be a little bit easier, and it's hard for me to share the share the notes as easily as I can. Okay. All right. So today what we're going to do is topic 1 and 2 for this video, and then if you need topic 3 and 4, 5 and 6 and 7, I'll be putting those on a future video. Okay. All right. So I'm going to switch screen. Okay. So this is what your guys' looks like here. You have your essential question, your topic 1, and then in between these you should have little pink things. If you click on them, then it will go down. Okay. All right. So the first one is, what is the composition of the Earth's interior and how do we study it? Okay. So if we go to the presentation, the topic question will be right. The essential question is right here. So I'll go ahead and post that for a little bit. Okay. I'm going to give about 10 seconds in between each part. So, but if you need more time, please feel free to stop and pause it. Okay. Now the vocab is interior. It's situated inside of something. So that goes with the fish right here. I do like these notes because they have the pictures, and if I were to have you in class, we'd probably just color it so that you guys can get this nice and neat. Okay, so the topic 1 is, how deep have we explored into the Earth's interior? Now I'm going to take, this isn't intended to, this is not intended to have you guys not do it. It's just so that you can take it step by step. Okay? All right. How deep have we explored? Well, we have a couple wells that I spent a little bit of time talking about, and also that expedition that's on the cusp of the mantle. It's just extremely hot. So the deepest blank on Earth is the blank borehole in the Koala Principle of blank. It is over blank and took over blank years to dry. Scientists can blank down and blank as we bring blank up to the surface. I feel like I'm in a movie where I'm cussing a lot. Okay, so you can fill that out while we're going. The deepest well on Earth is Koala Super Deep Borehole in the Koala Principle Peninsula of Russia. It is over 12 kilometers or 7.5 miles deep, and it took 20 years to drill. Again, they're not drilling just to drill. They're trying to find either water, oil, most likely, or some other precious material. Now, we've gone deeper and deeper and deeper, but as we go deeper, the temperature also goes up, and so does the pressure, because the density is going up. And when molecules are compact to each other, they start rubbing past each other. They start rubbing past each other, and therefore we create this really funky thing called friction. Okay, so 1% of the borehole is 1% of the Earth's center, and it's hot enough to bake cookies. So it's about 300 to 400 degrees. Problem is that we can start. You'll learn that the interior is mainly made up of metals, and if they're liquefied, hey, how are we going to drill down there and have something that is pressure resistant and heat resistant to those extreme conditions? Okay, so the next topic question is number 1. Still number 1. We're not at a different one. How deep have we explored into the Earth's interior? Scientists send instruments down to make observations as well, bringing up surface. So we can't go down there. There is a movie called Journey to the Center of the Earth where we find it's a book and then it's a movie. It's pretty good. Some subspecies of humans and all that, but in reality, that's not the case, except for, some miners, meaning like people chiseling stuff out of the, not young people, but miners, like coal miners or petroleum-based miners or anything like that. Okay. Now, so that will go right here. Okay. So number 2, we have the volcano and we have this really cool picture of the Earth. Okay. There's some things that we're going to learn within this that you may learn or not. And they're going to talk about some S waves and P waves. We're briefly going to talk about that in this, but in the next section, we'll be talking about some seismic activity. And if you don't know what that means, we'll discuss that. Okay? All right. So the topic question, again, this is not intended not to have you see it. It's just so that we can stay organized. How do scientists study the deeper parts of the Earth's interior? So that will go right here. Just click on that pretty pink box. It will click up and you'll just start typing. Okay, if you need more time, you can always just pause me. All right. So geologists use 2 main ways of evidence to learn about the Earth's interior. So that will go right here. Direct evidence from rock samples. Rocks are collected from wells or ejected by Earth by the Earth's volcanic eruption. So this is directly from the center of the Earth. This is not a cause and effect. This is just direct evidence. It's kind of like at a crime scene. I'm sure you guys have watched CSI or other materials or other programs where it's not circumstantial, meaning this person wasn't at his mom's house when he was supposed to. That's circumstantial because we don't have proof that they were there. But direct evidence is actual direct proof, like the DNA. And that's what rocks are. They're kind of the DNA of the different parts of the Earth. They're the DNA of what occurrences occurred right there on the spot. Okay, so the next slide. Now, this is more the circumstantial evidence. This is like, oh, Johnny Go was not at his mom's house when he was supposed to. There could be some circumstances that he was not where he was supposed to be. Same thing here. This is circumstantial evidence. This is just, hey, I'm feeling something here, so there's got to be a cause and effect. There's got to be an initial point. And that initial point is something occurring on the crust, causing seismic waves. Now, we'll discuss what those things occurring on the crust were in a future lesson, but they're actually going to talk about it a little bit here. Okay? So geologists record seismic waves produced by earthquakes and study how they travel through the Earth. The speed of the waves and the paths they take reveal the structure of the planet. Okay? And you can see here that there's 3 layers that we've come into it. And I'm not going to spend a lot of time on this, but we also have 2 types of waves. We have the red, the pink magenta wave that is felt, and we have the blue wave that's felt all over, but at different places, except for these 2 guys that don't feel those waves. Okay, that's right at 10 minutes. The next few are going to go a little bit faster, and you can always jump to the place that you need. All right.